Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is a portion of distributed forces. So you must first master derivation of formulas for volumes, areas and arcs or lines, and also familiar with them. And this part will be to enhance your thinking skills, especially in locating centroids of volumes, areas, and arc lines, which are necessary later in analyzing a system with distributed forces. Level 46. For the machine element shown, locate the y-coordinate of the center of gravity. So here's the given figure. We will call this element 1, the plate with circular section. Then 2 would be this rectangular parallelepiped. 3, this semicircular plate. 4 would be this rectangular parallelepiped. And 5, this circular plate that will be removed. So in locating the y-coordinate of the center of gravity, since it is homogeneous, then we'll just compute the volume. Volume 1 is pi over 4 times, or pi times 40 squared times 10, and that is 16,000 pi cubic millimeter. Then its y-coordinate of centroid, it is above the xg plane, so it is 5 mm. Volume 2 is along x 60, along y 10 mm, then along z 120, 60 times 2. So 60 times 10 times 120, that's 72,000 mm cube. And y sub c2 is, the centroid is below the xz plane, and the thickness is 10, so negative 5 mm. Volume 3 is semicircular plate. The radius is 60. This is 60 from here. So pi over 2, 60 squared times thickness 10 again. And it is equal to 18,000 pi. Then y sub c3, it is above the xz plane, so positive 5 mm. Sorry, negative 5 mm. It is below, rather, the xz plane. So this is the circular plate. The junction between this circular plate and this rectangular parallelepiped is the xz plane, so it's negative 5. Volume 4, this rectangular plate, along x, the dimension is 10 mm. Along y, it's not 100 because we consider the volume of 2, this 10 here, so 90. Then along z, 120. So it is 10 times 90 times 120. Again, it's not 100 because we included the 10 mm thickness in this rectangular plate already for this element 2. So what remains would be 100 minus 10, so 90 along y, then 10 along x, then of course 120 along z, so 10,800. Then the location of the centroid is, remember that the height is 90, so half of 90 is 45. 45 plus 10, so 55. So it is 55 mm below the xz plane, therefore y is negative 55. yc4 is negative 55. Then volume 5 is negative pi times 30 square. The thickness is 10. So it is negative 9,000 pi. Then y sub C5 is, of course, negative 50. It is indicated already in the figure. So the net volume would be the sum of these volumes, V1 plus V2, 72,000 plus 18,000 pi plus 108,000 minus 9,000 pi. So the volume is equal to 258539.82 mm cube. Then by Varignon's theorem, volume times Yg equals 16,000 pi times 5 plus 72,000 times negative 5 plus 18,000 pi times negative 5 plus 108,000 times negative 55, then plus negative 9,000 pi times negative 50. So solving for Yg is equal to negative 19.02 mm. Level 47, locate the center of gravity of the sheet metal form shown. So this is the sheet metal form. So we will call this element 1. By the way, by symmetry, xg is 125. So the centroid lies along this path. And since the radius of this semicircular plate is 125, so xg is 125 mm by symmetry. This is the axis of symmetry. Then yg and z sub g are to be determined. So call this element 1, element 2, element 3. Element 1, the area is area of semicircle, pi over 2, 125 square. So the surface area 1 is pi over 2, 125 square. It is 7812.5 pi, 7812.5 pi. So its yg is y sub c1 is 150 plus 80, 230. 230 plus the location of the centroid of semicircular plate from the diameter is 4r over 3 pi. So 150 plus 80, 230 plus 4 times 125 over 3 pi. So 150 plus 80 plus 4 times 125 over 3 pi, y sub c1 is equal to 283.05 mm. For surface area 2, it is the length of this curve or circumference times length, 250 mm. So remember that this appears to be a rectangular plate if you flatten this out. So the length, the base of the rectangular plate would be this length of the circumference, which is pi 80 over 2, because the circumference is 2 pi r and this is only 1/4. So 2 pi r over 4 is pi over 2 of r, which is 80, and the length is 250, 125 times 2, or the diameter of this plate. So by the way, C1 is 0 because the semicircular plate lies on the xy plane, so its z is 0. Surface area 2 is, as I said, pi 80 over 2 times 250. So 10,000 pi mm square. Then y sub c2 is 150. So since in this view this appears as an arc and the centroidal distance of the arc is 2r over pi, so therefore it is 150 plus 2 times 80 over pi. 150 plus 2 times 80 over pi, and that is equal to 200.93 mm, while the z is just 2r over pi, this distance here. So it is 2 times 80 over pi, gc2. and it is equal to 50.93 or 160 over pi. Then for element 3, the surface area is the length of this slanted length, which is square root of 80 square plus 150 square, then times 250. Surface area 3 is square root of 80 square plus 150 square times 250, and that is 42,500 mm square. Y sub C3 is half of 150 because this is just a straight length. So half of 150 is 75, while G sub C3 is half of 80, so 40. So applying Varignon's theorem, but before that, total surface area is 7812.5 pi plus 10,000 pi plus 42,500. So it is equal to 98,459.62 millimeters square. By Varignon's theorem, 98,459.62 times YZ is equal to 7812.5 pi times 283.05 plus 10,000 pi times 200.93 plus 42,500 times 75. So YG is equal to 167.0 mm. Then surface area total times G sub Z equals 7812.5 pi times 0 plus 10,000 pi times 160 over pi plus 42,500 times 40. So G sub G is equal to 33.52 mm. So we have XG 125, YG 167.0 mm, and G sub Z 33.52 mm as coordinates of the centroid or center of gravity of this sheet metal form. Level level 48. A thin steel wire with a uniform cross-section is bent into the shape shown. Locate its center of gravity. So for the solution, let's call this element 1, element 2, element 3, element 4. So for the length S1, 2.4, and its x coordinate of centroid is it lies on the YZ plane, so 0. XZ1 is 0. It lies on the XZ plane also, so YC1 is 0. And its Z1 is half of 2.4, so 1.2. S2 is 1 meter length. Then its x, it lies on the YZ plane, so 0. XC2 is 0. YC2 is half of 1, so 0.5. And ZC2, it lies on the XY plane, so ZC2 is 0. Then S3 is square root of 2.4 square plus 1 square. This is 1. So square root of 2.4 square plus 1 square is 2.6 meters. And Y sub C3 is X sub C3 rather is half of 2.4 midpoint, so 1.2. Y sub C3 is half of 1.5, and G sub C3, because this elementary lies on the XY plane, so it's 0. GC3, 0. Then this is element 4, the length is pi r over 2, pi times 2.4 over 2, so it is 1.2 pi meter. Then its x, it lies on the xz plane, so this distance is centroid of a quarter circular arc, 2r over pi, 2 times 2.4 over pi. XC4 is 2 times 2.4 over pi, so that's 4.8 over pi. Then y, because it lies on the xz plane, is 0, so yc4 is 0. And gc4 is the same as xc4, 2r over pi, 2 times 2.4 over pi, or 4.8 over pi. So the total length, or the net length, is 2.4 plus 1 plus 2.6 plus 1.2 pi, and that's 9.7699 meters. By Varignon's theorem, 9.7699 times xg equals 2.4 times 0 plus 1 times 0 plus 2.6 times 1.2 plus 1.2 pi times 4.8 over pi. So from here, we can solve x sub g. It is equal to 0.9089 meter. Then 9.7699 yg equals 2.4 times 0 plus 1 times 0.5 plus 2.6 times 0.5 plus 1.2 pi times 0. So yg is equal to 0.1842 meter. Then 9.7699 z sub g is equal to 2.4 times 1.2 plus 1 times 0 plus 2.6 times 0 plus 1.2 pi times 4.8 over pi. So z sub g is equal to 0.8843 meter. So that's it for this level 49 problem. Locate the center of gravity of the figure shown, knowing that it is made of thin brass rods with a uniform diameter. So here's the figure. Then we will, for the solution, let's call this element 1. Element 2 would be this OD. Element 3 DB. And element 4 this inclined sloping member AB. So for S1 is 1.5, the length 1 meter. XC1 is 0. YC1 is 0.75, half of 1.5, and GC1 0. So XC1 0, YC1 0.75, and GC1 0. This is the centroid. So you read the coordinates of the elemental centroid of the elemental coordinate 1, and these are the coordinates XC1 0, YC1 0.75, and GC1 0. S2 is 1. So XC2 is, of course, the centroid is here. Half of 1 is 0.5. Then it lies on the XZ plane, so YC2 is 0, and GC2 is also 0. Then S3, 0.6 length. Then XC3, the centroid is here, so 1, that's 1. And YC3 is 0, it lies on the XZ plane. GC3 is this distance, half of 0.6, so 0.3. S4 is, because this is straight sloping along X, so square root of 1 square, along Y 1.5 square, along Z 0.6 square. Square root of 1 square plus 1.5 square plus 0.6 square. And that is 1.9 meters. Then XC4 is half of 1, so 0.5, midpoint formula. YC4 is half of 1.5, 0.75 meter, and GC4 half of 0.6, so 0.3. So the total length is 1.5 plus 1 plus 0.6 plus 1.9, and that's 5 meters. Applying Varignon's theorem, 5 times x sub g is equal to 1.5 times 0 plus 1 times zero point 0.5 plus zero point 0.6 times 1 plus 1.9 times zero point 0.5. So xg can now be computed. It is equal to 0.4100 meter. 5yg equals 1.5 times zero point 0.75 plus 1 times 0 plus zero point 0.6 times 0 plus 1.9 times zero point 0.75. So yg is equal to 0.5100 meter. Finally, 5 times z sub g is equal to 1.5 times 0 plus 1 times 0 plus zero point 0.6 times zero point 0.3 plus 1.9 times zero point 0.3. So yg or g sub g is equal to 0.151500 meter. Level 50. A scratch awl has a plastic handle and a steel blade and shank. Knowing that the density of plastic is 1030 kg per cubic meter and of steel 7860 kg per cubic meter, locate the center of gravity of the awl. So this is the figure, and let's consider the leftmost end here as the reference of locating the center of gravity of this awl. So call the mass here as M1, and the mass is density times volume. This is a hemispherical plastic handle, so therefore mass 1 is 1030 times volume 2/3 pi 0.0125, 12.5 mm or 0.0125 meter quantity cube. So M1 is 1030, quantity 2/3 pi times 0.0125 meter quantity cube. So that would be in kilogram, and that is equal to 4.2133 times 10 to the negative 3 kilogram. For the location XC1, because we just want to locate the center of gravity along this axis by symmetry, so it lies on this axis here. So that's why X sub C1 is, remember, the centroid of a hemisphere from the diameter is 3/8 of the radius. Therefore, its distance, its center of gravity or centroid from the top or from the leftmost end is 5/8 of radius. 5/8 of 12.5 mm is equal to 7.8125 mm. M2 for this plastic here up to here, the length is 80 minus 50, so 30 mm. So M2 is 1030. The volume is volume of right circular cylinder, pi times 0.0125 square times height or length 30 mm or 0.03. So 1030 quantity pi 0.0125 square times 0.03. M2 is equal to 0.015168 kilogram. And the location of the centroid from the left is 12.5 mm plus 15, where 15 is half of 30. So 12.5 plus 15, 27.5 mm. M3 would be this right circular cylinder made of plastic less the volume of this steel cylinder. So M3 is 1030, quantity pi, open quantity 0.0125 square minus 0.00175 square. The radius of this steel cylinder metal, half of 3.5 is 1.75 mm, in meter 0.00175 meter. Then quantity square times the length 0.05 or 50 mm, 0.05 meter. So M3 is 0.024785 kilogram. M4, by the way, XC3 is 12.5 plus 30, 42.5, 42.5 plus half of 50, 25, 67.5. XC3 is 67.5 mm. M4 would be the mass of this entire cylindrical steel metal. The length is 140 mm or 0.14 meter. The radius is 0.00175 meter again. And the mass is 7860. So 7860 times quantity pi 0.00175 square times 0.14, the length. So M4 is equal to 0.010587 kilogram. Then M5 would be the, by the way, the location is 12.5 plus 30, 42.5, 42.5 plus half of 140, 70, 42.5 plus 70, 112.5 XC4, 112.5 mm. Then M5 would be the mass of this pointed conical steel metal, and it is 7860. The volume is pi 0.00175 square, 0.01 meter over 3. So M5 is 7860 pi radius square, height 0.01 over 3. So M5 is equal to 2.52074 times 10 to the negative 4 kilogram. And its location is 12.5 plus 80, 92.5 plus 90, 182.5 plus 1/4 of 10. Centroid of cone is 1/4 of the height from the base. So 12.5 plus 80, 92.5 plus 90, 182.5 plus 1/4 of 10, 2.5, so 185. XC5 is 185 mm. So the mass, the total mass of the assembly is 4.2133 times 10 to the negative 3 plus 0.015168 plus 0.024785 plus 0.010587 plus 2.52074 times 10 to the negative 4. So the mass of the assembly is 0.055005 kilogram, the mass of the all. Then by Varignon's theorem, mass 0.055005 times xg equals 4.2133 times 10 to the negative 3 times 7.8125 plus 0.015168 times 27.5 plus 0.024785 times 67.5 plus 0.010587 times 112.5 plus 2.52074 times 10 to the negative 4 times 185. So using your calculator there, xg is equal to 61.10 mm from the leftmost end. So that's it for this part.